Hi, my name is Jake Christoph Bonavista, and I'm doing my physics project on the types of energy on Build-A-Boat. So, let's go over the first one. So first up, we got electromagnetic waves. This thing with the different wavelengths. Yeah. So the ones that I'm primarily going to be using an example here in Build-A-Boat is the sun. Basically working by transferring waves of energy through multiple means, like the examples in the start, like it's mainly heat and stuff, which in this case, the sun giving energy to the plant. Now this next one is nuclear energy, and there are two types, but we should go over the nukes first. Yeah, that was more combustion energy, but I thought it would be a cool honorable mention for the nuclear energy bit because it looks like a nuke. I mean, come on. Anyway, yeah, so a lot of this cool looking stuff is by this guy, ready to go, so thank you to him for letting me borrow his stuff for this video. Traditionally, for nukes like this, they would be splitting atoms to make big explosion. And that's basically what this one is doing, as you can see it right now. Yeah, as you can imagine, the damage is catastrophic, like that. The physics engine can't really handle it, but this is the best kind of recreation of a nuke that we could probably make. But that's just nuclear fission, where they split atoms to create a lot of energy. There's also, however, nuclear fusion, which I don't really think is possible to recreate in Build-A-Boat either, but the closest thing we got was this thing that he showed me. I don't even know what this is, but it's just kind of like representing atoms that are trying to fuse together to form a star, which this is close enough because look at this. It exploded. I don't know what happened. It was weird. This is the best representation we got. So, yeah, nuclear energies. So now this one is sonic energy, which is sound. It sends out sonic waves in order to transfer this energy. And this is a lot of sound. I thought it would explode. Alright, now this one's hydro energy. It uses the energy of moving water to be transferred and reused. The energy isn't created or anything, it's just using the already existing water's energy that's like moving, so it can get reused. Or just for you to get pushed like a boat, you know. Next up is elastic energy, which we will be using a spring for. Other energies are just transferred over, which is what's happening here, except it's more like being stored, and it gets put back, returning to its original state. So let's take it a step further with this rocket. So I'm pulling on it, and there's elastic energies being saved up or whatever, and as soon as I turn it off, I get sprung back. Now, Build-A-Boat doesn't really have a wind mechanic, so let's just pretend that wind is pushing on the sail, and with the wind energy, we are moving. And it's definitely not the water. I can prove it. Right here, our mast, it breaks. And we fall, because there's no wind pushing on it, so it's just water now. That's definitely how it works, and it's the best example I got. So I thought I'd throw in the equation for the kinetic and potential energy bit, so please thank this volunteer for coming today. This will be a demonstration of kinetic and potential energy while I stand safely behind this blast-proof glass. Assuming our volunteer here weighs around 70 kilograms and the explosives will total to a velocity of around 5,000 meters per second, how much kinetic energy will hit them upon detonation? If you answered 1,750,000,000, you would be correct. These are strong explosives. Like, they're in the stratosphere, as you can see. The potential energy of the explosives combusted into a powerful amount of kinetic energy. Here's a recreation of that because it's really insane how far it goes. Alright, part 4, we're almost done. Chemical energy. There are two types. There are combustion and synthesis. Combustion being explosion, such as that, which we've also had many examples of already in the video. So let's focus on synthesis. Alright, so synthesis energy is weird because the main example that a lot of us know of probably is just digesting stuff. So there are candies in the game. They give you abilities, and I'm calling it similar enough because it does affect our player. They're consuming it, it's getting digested, and it's affecting the player. So that's our synthesis energy. So the main takeaway to be having from chemical energy is that it's kind of just stored energy that's kind of transformed, because for it to count, it has to change the compounds of it chemically. Like, you can't revert it to a previous state. So that's chemical energy. Alright, second to last part, thermal energy. So this energy type uses heat, and it's transferred energy through heat. You know, electromagnetic waves is being transferred. So let's cook in this marshmallow. You have to be careful though, it can burn. Like that. This is used in many places. Like, even the orbital strike station had to steam off because it was so hot. So yeah, thermal energy is everywhere, and it's just the transferring of energy through heat. Last one, electrical energy. It is just energy related to the flow of electricity, and it's being transferred and transformed into other energies to be used in technologies and whatever. Electrical energy. It powers stuff. It's what we mainly use. And those are all the energies. Thank you. I'm done. Good night.